Good morning. My name's James Danger, and today's video is about comparing the live birth rates between the transfer of Mosaic and Euploid embryos as part of my Euploid embryos video series playlists. This video is based on an article that appeared in the Journal of Assisted Reproductive and Genetics. I think it's a really fantastic journal, entitled Mosaic Embryos Result in Equivalent Live Birth Rates when Compared to Euploid Embryos Following Frozen Embryo Transfer, published a couple of days ago, January 29th of January 2026, by a group of authors from America. There is the link you can get if you like. Basically, there are two views on mosaic embryos. About 20% of all embryos tested by PGT-A are reported to be mosaic. And unfortunately, the level of mosaicism varies from very mild, just a few segmental changes, to a high level where a multiple number of chromosomes are missing or in increased number. The interesting thing is often they're only transferred when euploid embryos are no longer viable, and hopefully after cancelling about the risks. Several studies have, however, shown that the transfer of low-level mosaic embryos have similar outcomes compared to euploid, and some studies have suggested that many mosaic embryos contain abnormal inner cell mass. So this study, the purpose of it was to compare the live birth rates between the transfer of mosaic and euploid embryos, and it's from a group in New York. It's a retrospective study comparing the transfer of 56 mosaic embryos to 119 embryos tested over a 5-year period, 2018 to 2023. The primary outcome was live birth rate, but they also looked at miscarriage rates, implantation rates, etc. So as I understand from the data, there were 56 mosaic embryos transferred in 49 cycles, and 118 euploid embryos transferred in 793 cycles. And the authors indicated that the two groups where they were transferred were basically similar. So because at 56 mosaic embryos in 49 transfers, I've calculated that actually made up of 43 single embryo transfers and 6 double embryo transfers, and this is important a bit later on. And for euploid embryos, there were 767 sets and 26 double embryo transfers. So one interesting thing, the numbers in the study are not high, as you'll see in the next slide, but I'm using it because I think it reflects what many normal-sized clinics may experience. So despite some limitations such as mixing single and double embryo transfer together, it's kind of like real-time data. This is what a clinic may expect to find if they did mosaic embryo transfers over a period of 4 to 5 years, and may represent, therefore, a valid reference point for them to counsel their patients about the risks. So here's the data, table 2, and the important things are mosaic embryos and euploid embryos. All these values are basically non-significant. Live birth rate per embryo transfer, the live birth rate per cycle, 49 to 52. The implantation rate per embryo transfer, because some of these were single doubles, 55, 56. Biochemical pregnancy rate, 22 to 18. Clinical pregnancy rate, 53 to 56. Miscarriage rate, 7.7 to 7.6. Basically, they are almost virtually identical. There are two lines here which I'm a bit annoyed that they're in there. This is the number of cases that double embryo transfers. I actually think this is incorrect. And if I'm wrong in my assessment, this is correct, and the authors see this, then they're welcome to make a comment after the video. I actually think it's a lot less than that, but there was sufficient to get far more twins, 5 out of 24, 21%. But that, I think, is a funny sort of statistic because this is all man-made. So just a few points. Looking at the data, I've had a glass of wine, thought about it. Like lots of sets of data, it's very similar to lots of other reports. Basically saying, the way I look at it is, whether you're transferring 1 or 2 euploid embryos gives you a successful implantation rate about half the time, about 50% of the time. The difference between the actual implantation, that's where an embryo is implanted, as opposed to the chemical pregnancy rate, and successful pregnancy is only about 4%. In other words, nearly all the embryos you put back that do implant is a viable pregnancy. There's very few failed embryos implantations. However, it means that only 50% of embryos, euploid embryos, still fail to succeed to successfully implant, or the conditions for implantations. These were all natural cycle FETs, were less than suitable, or we still don't really understand the interaction between embryo and the uterine epithelium. We make a lot of effort to create these, euploid embryos, but we still don't really understand the implantation process. So maybe we're actually really good at making blastocysts and forget. So let me go back and I apologize. Maybe we think we are just so good at making blastocysts and forget that maybe the controlled ovarian hyperstimulation system and the embryo culture systems are really not as good as we think they are. Those embryos might be euploid, but they're still rubbish. Or it may well be that the implantation potential of each embryo could be much higher than 56%. And remember, it could actually be that the endometrium is not, or the environment's not successful, but also that we're biopsying the trophectoderm, but it's the mural trophectoderm they're biopsying, but really it's a polar trophectoderm that overlies the interstitial mass that actually is attached, causes the attachment, not the biopsy trophectoderm. And maybe those two definitions are different. There's another slide there which is okay. Basically, it says the live birth rate day 5 and day 6 is virtually similar, and I think that's not seen by all clinics. Normally, the day 6 and 7 embryos implanted at a lower rate. What's interesting here is the whole mosaic embryos, that is where the cells actually miss or have extra chromosomes, as compared to the segmental ones, are very similar. But if there's a high level of mosaicism, that is, many of the cells are aneuploidy, then that's the pregnancy rate is a little bit less than if there's low level. That's just less than 50%, 0.18. But I make my point, if I double this number here, that suddenly becomes significant. And once again, good quality embryos appear to do better than poor quality embryos. So just to summarize it, per embryo, mosaic and euploid embryos have similar live birth rates, implantation rates. Per cycle, biochemical rates, clinical pregnancy rates, and miscarriage rates are also not different, but remember the sample size is small. Live birth rates in high and low mosaic are not significantly different, 59% to 37%. But remember, if you double the sample size, this becomes significant. So it really is just a matter of, you can't actually say it's not significantly different. You can just say the sample size didn't allow you to pick the difference up. Mosaic embryos transferred in slightly older patients, but the age did not affect the live birth rate. That's fair enough. And that they made the observation that double embryo transfers are more frequent with mosaic than euploid. That was a decision of the clinic. But the important thing, and even though there are only 56 embryo transfers, not really enough to make any real conclusions about the neonatal outcomes. The important thing is that they could not detect any difference between mosaic and euploid. Birth weights are similar, and there are no detectable congenital abnormalities that they saw. But really, that's just a small number of babies born. And then they basically go and say the mosaic embryos had nearly identical live birth rates to euploid, supporting their transfer before repeating another oocyte retrieval. And given the elevated twin risk from mosaic death, single embryo transfers should be prioritized for all tested embryos. In other words, the idea that a high twin rate observed in mosaic transfers are largely due to the increased use of double embryo transfers involving 2 mosaic embryos in an effort to increase the likelihood of pregnancy rather than the intrinsic biological properties of embryos. Sometimes it's a mouthful. Basically saying they thought that the mosaic embryos had a lower chance of implantation, so putting 2 back gave them an increased likelihood of outcome. But in reality, they now say that was an incorrect assumption, and since they seem to behave the same, they should all be put back as single embryo transfers. And just finally, there's been a few comments and thoughts about why mosaic embryos appear to produce healthy children. And these include one theory that suggests that embryos possess the ability to self-correct, with euploid cells outcompeting aneuploid ones through a mechanism like apoptosis and autotrophy. Another is that there are limitations in the testing process itself. Next generation testing determines mosaicism by inferring intermediate chromosomal copy numbers, but factors such as test artifacts, amplification bias, contamination, and variability in lab techniques can produce false positives. And lastly, these are comments from the authors, lastly, that cells sampled from the trifectodome may not accurately represent the genetic composition of the inner cell mass, which ultimately forms the fetus. And they quoted one paper published in 2020 by a very proliferative group, do some really fantastic work, and I like to review some of their recent publications. But they produced an article saying autophagy mediated apoptosis eliminates aneuploid cells in mouse models of chromosome mosaicism. They say the high level of aneuploidy in the embryo is considered the principal cause of low human fertility. However, the prevalence of aneuploidy dramatically declines as pregnancy progresses, with the steepest drop occurring as the embryo completes implantation. Despite the fact that the plasticity of embryos in dealing with aneuploidy is fundamental to normal development, the mechanisms for eliminating aneuploid cells are unclear. Using a mouse model of chromosome mosaicism, we show that aneuploid cells are preferentially eliminated from the embryonic lineage in a p53-dependent process involving autophagy and apoptosis before, during, and after implantation. Moreover, we showed that diploid cells in mosaic embryos undertake compensatory proliferation during the implantation stage to confer embryo viability, and together our results indicate a close link between aneuploidy, autophagy, and apoptosis to refine the embryonic cell population and ensure only chromosomally fit cells proceed through development of the fetus. That all sounds rather exciting, but I just need to make a point. It's not a very good slide, I'm afraid, that the way they came to this conclusion was they took mouse embryos, they deconstructed, they tested, they exposed these embryos to various degrees of stress, deconstructed, then reconstructed chimeras, grew them up, underwent immunosurgery, and then grew them on further to look at the number of healthy cells. So it's a far cry from the human world. And lastly, there's an interesting article in 2020, this is a while ago, from Paulson in Fertility and Sterility Reports. He makes a comment. These are selective quotes from that paper. Laboratories offering PGT are reporting mosaicism rates which vary widely. It's possible that the measurements are real and the mosaicism varies with embryo culture or ovarian stimulation. However, it's much more likely that these differences reflect variations in laboratory techniques, biopsy methods, DNA amplification protocols, threshold settings, and data analysis approaches. In an ideal situation, laboratories would analyze individual cells obtained from the trifectoderm biopsy rather than a pooled sample. And there have been two papers. Basically, they're both non-open access, but they both basically say this is the important one. This was published July 2025. Our findings indicate that mosaic embryos have significantly lower implantation and live birth rates than euploid embryos, reinforcing the superior reproductive potential of euploid embryos. However, they make the point, this is from their abstract, once the implantation occurs, biochemical pregnancy loss rates, and miscarriage rates were comparable between the groups, suggesting that implantation is the primary limiting factor in mosaic embryo viability. The type and extent of mosaicism may further influence reproductive outcomes, with segmental mosaicism showing better prognosis than whole chromosome. Okay, so just to finish up my views, mosaic embryos are a product of embryo development and exist both in vitro and in vivo. There's a wide variety of types of mosaicism, enough to confuse most IVF clients and staff. And that's important because if you have to try and explain to people why you're putting back a non-euploid embryo, it gets really difficult to explain that. Initially discarded, recent reviews of testing for aneuploidy and mosaicism has highlighted significant technological variability, testing and setting of thresholds. That is, there is a real potential for artifact in identifying the degree of mosaicism. It's a real worry. The problem is that trophectoderm is being sampled, but it's the inner cell mass that makes the fetus. In humans, the area of the trophectoderm that initiates attachment to the endometrium epithelium is the polar trophectoderm, and this lies directly over the inner cell mass. But there is a growing body of information to suggest that inner cell mass may actively discard non-euploid cells, making the inner cell mass, the epiblast, the endoderm increasingly viable over time. So here's the suggestion, is that as the inner cell mass starts to proliferate, it increasingly compensates for abnormal cells which get discarded or left behind or removed by apoptosis. And so the process of improving the viability of the inner cell mass is a dynamic over time, and testing early on day 5 may not give the embryo credit for its ability to transform itself. However, all the studies have suggested there doesn't appear to be any increased risk of neonatal abnormalities. That's until it's tested in court, and then we'll let you know what the data really is. There's even been some reports that you can transfer aneuploid embryos which may produce healthy live births even at a lower rate, although I think any clinic doing that is asking for trouble. But we do know, we've had 50 years of information from IVF where we know it's safe to transfer untested embryos. So there's no reason for not transferring tested mosaic embryos. We do know the miscarriage rate is halved when euploid embryos are transferred, and it may well be that mosaic embryos will ultimately be somewhere between euploid and untested embryos. However, deciding to transfer a non-euploid embryo and relying on nature to fix it and the risk itself is very risky. I didn't say that right. Sorry, I'll try that again. By deciding to transfer non-euploid embryos and relying on nature to fix it is in itself rather risky. It's risky because the clinician has to be able to understand the risks associated with each time mosaicism, and it all depends on the skills of the clinician, the genetic counsellor, on whether clients can understand what increasingly is a complex issue. While not critically important, implying that euploid and mosaic embryos have similar likelihood of pregnancy basically makes them pseudo-euploid. There are implications in how they are stored and documented in the patient's file and other documentation, e.g. reporting for national reporting and for interclinic transfers. And I think there are potential legal ramifications in transferring non-euploid embryos, and you won't know until an abnormal baby is born and a couple takes it to court saying they didn't understand what they were signing. In reality, this issue is one of the industry's own making, given our drive to find the best euploid embryos. However, the concept of trying to define an embryo by being euploid, non-euploid, or mosaic is only just the start of how we define embryos and new ways of testing the viability, looking at spent culture media for signs of mRNAs, etc., and polygenic testing will only add to the potential confusion in describing embryos. Okay, I think that's enough. My name's James Danger. I'm a professor with more than 50 years experience in embryology. These videos are my attempt to bridge the gap between information you may need for your fertility treatment and the most recent publications, but I'm not a medical person, and this information is not medical advice, but it may help you knowing what questions to ask about your treatment with your doctor, particularly now with mosaic embryos, and may help you in understanding the advice you receive. If you like what I'm doing, press subscribe and tell everybody else that you think these videos are a good idea, and leave a comment and press like. Just like to acknowledge that my other activity is a Third Aid company, which is the primary sponsor of this channel. Third Aid is an online EQA and training program in IVF and embryology, and I think I'll leave it at that. I'd just like to thank you for listening to the video. I know IVF is a personal journey that involves the action of many different techniques, ideas, concepts, and people. It helps to understand all aspects of that journey, and I hope this information has value. If you like the information provided, please tell other clients about this service and please subscribe. And at this point in time, I would like to say goodbye.